In the examples we've covered so far, every problem ended up with two solutions. But that won't always be the case when we solve these absolute value equations. In the next three examples, we want to take a look at some of those cases where we end up with fewer than two solutions. In example 8, we have a problem where the absolute value portion is already isolated. So if we apply our approach that we've been using so far, we would end up with two statements. 6x minus 3 is equal to 0, and 6x minus 3 is equal to the opposite of 0, which is still just 0. In this case, both equations that we set up are exactly the same, so there's no need to solve that same equation twice. Adding 3 to the other side of our first equation would give us 6x is equal to 3, and then x is equal to 3 over 6, or 1/2. So in this case, we only come up with a single solution, x is equal to 1/2, which will be the case anytime we have an absolute value function set equal to 0. In example 9, we can continue trying to apply the same approach that we've been looking at so far. We would set up u minus 7 is equal to negative 2, and then we could set up u minus 7 is equal to the opposite of what we have on the right hand side, and then solve those two equations. With our first equation, we would add 7 to the other side, which would give us u is equal to 5. And with our second equation, we would add 7 to the other side, which would give us u is equal to 9. If we go back and try to check these solutions though, by first plugging in u is equal to 5, we would get the absolute value of negative 2 is equal to negative 2, which is not true, which tells us that u equals 5 is not a solution. So we can scratch this value. We can do the same thing with u is equal to 9. So plugging that back into our original statement would give us the absolute value of 9 minus 7 is equal to negative 2, which would give us the absolute value of 2 is equal to negative 2, which is also a false statement, meaning u equals 9 is not a solution. So what we end up with in this case, if we apply that same approach we've been using in our previous examples, we can essentially solve the problem, but we come up with two values that aren't solutions for the original statement we were given. And really what we should do is be able to catch on to this a little bit earlier, because we already know that the absolute value of x always has to be a non-negative result. So as soon as we have an absolute value statement set equal to a negative value on the right hand side, we know that's impossible because negative 2 is actually less than 0. So anytime we have an absolute value function set equal to a negative, these steps that we worked out here are really just kind of irrelevant. We should just be able to jump straight to saying that there is no solution in this case. Or the other way to say that would be that the solution is the empty set. So there are no values that would make that absolute value statement true. In example 10, we have one of these more complicated examples to consider, where our absolute value portion isn't isolated. And initially, this looks like it might have a solution, since we do have this set equal to a positive value on the right-hand side. But as we work to solve this absolute value problem, by first subtracting 3 to the other side, and then dividing both sides by negative 2, what we end up with is that absolute value statement set equal to negative 2, which can never be the case. So we don't need to solve anything, we don't need to do any additional work from here. Once we have that absolute value portion isolated, if that ends up being set equal to a negative number, then we know that we have no solution. Or again, we could say that the solution is the empty set. So while in a number of cases we'll end up with absolute value problems that have two solutions, we do need to make sure we're looking out for these cases where we could have just a single solution or cases where no solution exists.